Every day we enter password to log into different systems time by time, and each system has its own password requirements. We have to follow these guidelines when we first time create the password or every time reset it. These guidelines can be as simple as to allow you to use your phone number, but most of them have very strict and odd requirements. It's not easy to find one that can satisfy all requirements and yet we can still remember it. The most insane guidelines that I encountered ask me to create longer than 12 characters password and must include all types of input, like numbers, uppercase letters, lowercase letters, special characters, and the letters and numbers must be unrepeatable and inconsecutive. And you can't reuse your last 5 passwords. What the Now, have you ever wondered how secure these guidelines are? Or what kind of guidelines can better protect you? The more complicated, the better? Well, the results can be totally different depending on many factors. Let's take these two systems for example. To better compare, let's ignore these two trivial items for a while. So they look quite similar now. Basically, they all require 3 things. Password length. The left system asks for 8 to 20 characters, and the right one asks for 7 to 20. Numbers. Both ask you to include at least one number. Letters. The left system asks for at least 2 letters, one uppercase and one lowercase, while the right system only asks for at least 1 letter. Can be either lower or uppercase. So apparently, the left one is more strict. We don't say it's better for now, but at least we agree it is the more strict one. Now, to compare their securities, before involving any mathematics, let's first derive it in a qualitative way. Imagine that if you are a hacker and you target on those lazy users in the system who only satisfy the minimum requirements when creating a password. Trust me, there are always quite a number of these kind of users, especially when a system has millions of users. This is something for sure. Now, which system's requirements will cause you, the hacker, feel more headache to guess a password? It's the left one, right? For the right one, you only need to consider 7 characters, including at least 1 number and 1 letter. If you are lucky enough, probably the simplest one you'll start with, say A000000, belongs to 1 user. But for the left one, you need to add 1 more character and consider to add 1 more letter in a different case. So from the attacker's view, the left one is more painful. QED. Wait, remember the question we asked at the beginning? Which system can better protect you? So, are you a lazy user? If the answer is no, then how much effort would the hacker take to find you? If a hacker doesn't know how many characters in your password, doesn't know how many numbers you used, how many letters you used, upper or lowercase, any special characters involved or not, for the left system, the hacker needs to try all qualified combinations in 8 characters, 9 characters, all the way to 20 characters. Well, by contrast, for the right system, the hacker even needs to try all qualified combinations starts from 7 characters, plus those passwords with only 1 letter, which are not qualified in the left system, plus those passwords contains letters all in the lowercase or all in the uppercase, which he or she doesn't need to consider when dealing with the left system, since they are not qualified. So the new fact we just discovered is the qualified passwords the hacker can guess for the left system is just a subset of those for the right system, which means it will take a hacker to spend more time to traverse in the right system. So the right one can protect you better. It's like If you want to hide yourself from a hunter, you'd better run into a larger forest. Even a rabbit knows that. Now I think you should know what to do in the future, right? The next time you see a system with simple password requirements, you should feel safer as long as you can create a complicated one and drop it into this full of randomness pool. Now, if you ever learn some basic knowledge of combination mathematics, you can even compare them in a quantitative way by calculating the search space for each of them. Basically, we need to calculate how many combinations attackers have to try in the worst case if they perform a brute force attack, which means we try each combination one by one until succeeded. This number of attempts in the worst case is called the search space. For example, if you have 7 keys in a key ring in your pocket, and somehow you forget which key is the right one to open your office door, then the search space would be, in this case, 7. That is, in the worst case, the last key you try is the right key. Yeah, I know you must have this kind of experience 1 or 2 times in your life, and what I want to say is you are not alone. To make it simple, I only show the 8-character cases for illustration. Now for the left system, we need to choose one from these 8 characters and assign a number to it. To satisfy this condition, where we have 10 possible choices, so times 10 for this position, then we need to choose one from the remaining 7 characters and assign an uppercase letter to it in order to satisfy this condition. Where we have 26 candidates, so times 26 for this position, and then again, choose one from the remaining 6 characters and assign a lowercase letter to it. Here we have 26 options again. For all other 5 characters, there's no restrictions. So we can use any character that can be typed out. So it's 10 digits plus 26 uppercase letters plus 26 lowercase letters and all special characters. Suppose here we can type this many, 32 special characters. Then it is 94 for the left 5 positions. So the result of this search space is 1.67 times 10 to 16th power. Now consider the right system. Choose one from the 8s and assign it a number. And choose one from the remaining 7 characters and assign it a letter, case sensitive. So it's 52. For all other 6 characters, no restrictions. Actually, here has one requirement, so it's 94 minus 2 to the 6th power, which is 1.76 times 10 to the 16th power, which is larger than the left one. Now to mention we only consider 8-character cases. The total search space will be the result generated from 7-character cases plus the results from 8-character cases, and all the way until we plus the result from 20-character cases. For the left one, it's only from the 8-character cases to 20s, which makes the right search space even greater than the left one. So we can generate the same conclusion as a quantitative analysis. In the end, please remember, the larger search space a system can generate, the better it can protect you from a password breach, if you are not a lazy user. By the way, the calculation here is only to simulate attackers' brute force password generating process. It contains repeatable cases. The theoretical search space is less than the results we showed. For example, for a 3-character password with the right system's requirement 1AB, it is counted when the second position is chosen to be the letter, the first to be a number, and the other is wildcard. It is also counted in the same combination when the last position is chosen to be a letter, the first to be a number, and the other is a wildcard. To calculate the true search space, we need to separate possible combinations into unrepeatable groups in order to eliminate wildcards in your calculation, which is a factor caused the repeated counting. Keep using this example. We should derive them into two groups. One is filled with two letters, one number combinations. The other is two numbers, one letter combinations. The two groups are mutually exclusive, no ambiguous part. For the first group, we can choose one character from 3 as a number, and all others are letters. For the second group, we choose one of them as a letter, and all others are numbers. By adding them together, we get the total search space. This will make the calculation really complicated when the number of characters in the password increased. Or you can calculate it by deducting violating cases from all possible cases. This may be super easier for certain requirements. In this example, we only need to compute those combinations with all allowed characters and then exclude those with all letters and further exclude those with all numbers. And the rest will be those combinations including at least one number and one letter.